Think you know our neighborhood? Think again. 10 minutes of jaw-dropping solar secrets. Beyond the familiar blue marble and the red plains of Mars lies a universe of cosmic wonders, right here in our own solar system and its immediate vicinity. These aren't just distant, fuzzy concepts. They are real places, bizarre worlds, and mind-bending phenomena that challenge everything we thought we knew about how planetary systems work. We're about to embark on a journey to the stranger side of space, a place where planets have two suns, moons, spew oceans into the void, and entire worlds are being eaten alive by their stars. Pause. The cosmos is not a quiet, orderly place. It's a dynamic, often violent, and endlessly fascinating theater of creation and destruction. The laws of physics, the same ones that govern our lives here on Earth, give rise to unimaginable diversity out there. We'll see worlds with methane rain and icy shells hiding vast, dark oceans. We'll encounter celestial travelers from other star systems and planets wandering alone in the galactic dark. This isn't science fiction. This is the reality of our cosmic backyard. Pause. In the next 10 minutes, we're going to peel back the curtain on 10 of the most jaw-dropping secrets our solar system and its neighbors have to offer. Prepare to have your mind expanded. The journey starts now. Imagine waking up to not one, but two suns rising in the sky. This isn't a scene from a galaxy far, far away. It's a reality on a planet named Kepler-16. Discovered by NASA's Kepler Space Telescope, this gas giant, roughly the size of Saturn, orbits a binary star system. That means it has two parent stars, a smaller orange dwarf, a larger K-type main sequence star, locked in a gravitational dance. The planet orbits both of them from a distance, like a child circling two dancing parents. Kepler-16 proved circumbinary planets are real. Its discovery opened a whole new category of planetary systems. You could witness a double sunset, one star dipping below the horizon, then the other, or setting together, casting overlapping shadows. The interplay of light and gravity would create seasons and weather patterns completely alien to our own. Kepler-16 is a cold gas giant, but it suggests smaller rocky worlds could form in binary systems. Now let's travel about 40 light-years away to a cosmic bullseye. The TRAPPIST-1 system is extraordinary. A tiny, ultra-cool star, barely larger than Jupiter, with 7 tightly packed, Earth-sized worlds. Among them, TRAPPIST-1e sits squarely in the habitable zone, just right for liquid water. If you stood on its surface, other planets would hang as visible disks, some as large as our moon. You could watch their phases, see continents and clouds drift by. These worlds are likely tidally locked, one hemisphere in endless day, the other in night, with a temperate twilight ring. Here, temperatures might permit liquid water, and maybe a foothold for life. With James Webb, we analyze atmospheres and search for signatures of water, methane, and other potential biosignatures. TRAPPIST-1e is a prime target in our search for life, a place that could rewrite our place in the cosmos. Not all planets live long, peaceful lives. Some are locked in a mortal struggle with their parent star. Meet WASP-12, 870 light-years away, a planet being devoured. It orbits blisteringly close. Its year is just over 1 Earth day. Its dayside bakes near 2,500 degrees Celsius, hotter than some stars. The atmosphere swells like a balloon, nearly twice Jupiter's size with only 40% more mass. Gravity distorts it into an egg, while the star siphons its bloated air into a disk. It's losing about 200 quadrillion tons each year. In a cosmically brief 10 million years, it could be gone. What's more, it's one of the darkest planets known, absorbing over 94% of incoming light, glowing like an ember. A stark reminder, the universe is not always a gentle cradle. Let's return homeward, to Jupiter, and a world that may be our best bet for finding extraterrestrial life, Europa. On the surface, an unassuming bright orb crisscrossed with reddish-brown cracks, like fractured porcelain. Beneath lies a global ocean, possibly twice the water of all Earth's oceans combined. Floating ice and chaotic terrain hint at a liquid layer below. Jupiter induces a magnetic signature best explained by a salty, electrically conductive ocean. Tidal flexing warms Europa from the inside, sustaining liquid water. It could even power hydrothermal vents. On Earth, cradles for life in eternal darkness. Tantalizing evidence points to plumes that may sample the ocean directly into space. NASA's Europa Clipper will scan the ice, confirm the ocean, and fly through plumes to taste the water. Europa isn't just a moon. It's a scientific holy grail that could answer, are we alone? While Europa hides its ocean, Enceladus puts it on display. From its south pole, enormous geysers eject ice particles, water vapor, and simple organics. These plumes even feed Saturn's vast E-ring. Cassini flew through them, finding salt, silica nanoparticles, and organic molecules, including methane. Silica forms at hot vents, smoking gun evidence for active hydrothermal systems beneath the ice. Enceladus has the key ingredients: water, energy, and organic chemistry. Best of all, it delivers samples for free. Titan looks eerily familiar and profoundly alien. With rain, clouds, and seasons, its hydrological cycle runs on liquid methane and ethane. Huygens showed floodplains strewn with rounded ice pebbles, smoothed by hydrocarbons. Sunlight and particles forge complex organics that rain down as tholins. Prebiotic chemistry reminiscent of early Earth. Could life exist here? If so, it might breathe hydrogen and metabolize acetylene, life as we don't know it. The Dragonfly mission aims to fly, hop, and probe Titan's chemistry in situ. Orbiting Mars is Phobos, a battered potato-shaped moon etched with long grooves. It races around Mars 3 times per Martian day. Low density hints it's a rubble pile. Some grooves likely carved by ejecta bouncing from Stickney crater. But Phobos is in a death spiral, about 2 meters closer each century. In sub 50 million years, tides will tear it apart, making Mars a ringed planet, briefly, before debris rains down. Well, that's pretty eerie. Oumuamua, the interstellar messenger. In 2017, we detected our first known interstellar visitor. Its brightness variations suggested an oddly elongated or flattened shape unlike typical asteroids or comets. It sped up after the sun without visible outgassing. No tail, no coma, confounding expectations. Ideas ranged from invisible hydrogen to an ultra-fluffy dust bunny pushed by sunlight. Some even posited alien technology, a solar sail, though most favor natural explanations. A fleeting messenger that left more questions than answers. Far beyond Neptune orbits Haumea, a dwarf planet shaped like a spinning egg. It rotates every 4 hours, so fast it's stretched into an oblate shape. A primordial impact likely set it spinning, scattered a collisional family, and formed its 2 small moons. In 2017, an occultation exposed a faint ring, first for a Kuiper Belt dwarf planet. Not all worlds keep their suns. Rogue planets wander the galaxy untethered. Early system chaos can sling smaller worlds into interstellar exile. We find them via gravitational microlensing, rare, brief magnifications of background starlight. Some models suggest they may outnumber the stars themselves. With thick hydrogen, internal heat could keep subsurface oceans liquid for eons. From planets with 2 suns to worlds being eaten alive. From hidden oceans to cosmic wanderers, our universe is stranger and more wonderful than we imagined. Each new discovery gives answers, and a dozen deeper questions. We are just opening the first page of the universe. Subscribe to keep exploring. Fade to black. Next episode, the stranger side of exoplanets.